All right, so I have just started the recording. Anyone that does not want to participate in the recording, unfortunately, have to log off of the meeting. With that said, thank you all for coming today. On this demo, we will be covering shackle for IMF types. We'll look at the restrictions these entail and which updates we have made in order to make the validation more correct. With that said, I want to hand over the word to Bård, which is the one presenting today.
Oh, thank you, Felix. Yes, today we'll talk about shackle and more precisely the IMF types that we described using shackle. So this will be fairly technical. We'll go down into the details and well, basically start at the top and then work gradually down into a more detailed view of these types. And so I will try to combine this with a presentation, see if that can make things a bit more understandable, and then also use this shackle playground tool to actually show how the shackle is validating an instance of an IMF type. All right, so we have here a type on the left-hand side, a shackle type of a temperature transmitter, and then we have an instance on the right. And the instance, that is basically the data that an end user typically will see. And the shape on the left-hand side is what is used to validate this information. I'm not sure, perhaps it's a bit small, but this is unfortunately the best I can do. Yeah, I think so. Let's see if I can bring it up. No. No effect of zooming here. All right, so let's see. We have several different properties when it comes to our shackle. We have what I called IMF-specific properties, and then we have some reference data that we've chosen to use directly. And then we have a regular IMF attribute, a range IMF attribute, the terminals, and the blocks. And all of these different parts of the shackle, we will go through them in detail, or might treat them individually, so it's easier to follow and easier to see. So when it comes to the IMF-specific properties, we basically have here, let's see, we have this, this is the shackle shape now here, and they have this, that's a property, shackle property, that has a path, and this path is what we find again in the instance itself as the predicate in this triple. So the path of the shackle property becomes the predicate, and the value becomes the object in the instance triple. And in this case here, I'll put a red little marker underneath here because the product aspect should have been the value. In this case, it's just product in the instance. So that should lead to a validation error. All right, so now this is what I'm, again here, now we're back in this shackle playground validation tool. So on the left, we have a shackle shape. On the right, we have the data, the instance that we use. And down below, we have a validation report. And now the validation report is based on that this instance is being validated by this shackle type. So the first thing to notice about shackle is that if I change this, I say here that this, my transmitter, my instance of a transmitter, is of the type, and this type is the same as the shackle shape. And if I change the my identifier here so that my transmitter is not longer of the type of the shape, then it will not be found. We will not have this link between the instance and the actual shape. And we've done a trick here, so we are actually using the shape and the actual type of the instance as the same individual, or the same, I'll put it. We have here that the shekel shape is also the class, which is the class of this transmitter. And therefore, we need to make this transmitter of this type. Let's see. Back again there. Okay. And then we have these. So this is what makes the validation happen, that these two are linked. And the first error in my validation report is that we are missing this expected value of product aspect. So if I go up here now and I change this to, it should be product aspect, shouldn't it? Product aspect, like that. Trying to update that again. And we see that now my error here is gone. So that's the first thing. We have used this combination of, let's see, use this combination of path and value to specify that this information needs to be in place exactly as is. And we have some of those in the IMF manual, some properties that just need to be in place. Let's see. Moving on. Then we have these things that use the reference data directly. So we have not wrapped them in an IMF attribute, we just use them directly. And this here is an example of the manufacturer, and this is the manufacturer name. And instead here, we don't have a value, but we have used these cardinality numbers so that we can say that manufacturer, well, that is required, but the manufacturer name, well, that is optional. You don't have to include that if you don't like. So this is how it looks in the instance. I've just said that, okay, the manufacturer, and then I put in a link to actually the Brennusregister and found Aker Solutions ID there. And you can move to the, you can navigate to this URI and find more information about Aker Solutions, which I've used in my example here. So this is just me trying to encourage us as an industry to use more linked data. Instead of using kind of the textual thing here, the literal, we can use the URI to link our data more. So how would this look in, we don't have actually any errors in this on my validation report, but we can try to, for instance, just remove this, that we don't have a manufacturer here. That was required, right? So if I remove this and update, we should have a new validation error saying that, well, we don't have this value. On the other hand, if I do the same with the manufacturer name that was optional, all right, this should still pass. Right, and we got only 5 errors, so we don't have kind of that validation. We didn't get an extra validation error based on removing this optional parameter. Introducing it again, let's see it. Introducing it again, just checking that we still have the same, yes. So that's an optional parameter. Don't need to include it. All right. The next is the IMF attributes, and those work exactly the same way as now the reference data used directly. We have a path that should point to an attribute, an existing attribute, and then we have these cardinality numbers that say something about is this required or not, or an optional. And then we have how it's used down here. And I'll put a little warning here because the IMF manual states that this is how it should be instantiated. So there's a bit of a, we've made some simplifications there in how it's used. Instead of actually referencing an attribute instance with the IMF has attribute predicate, and where you define the attribute instance in your data, we said that, well, you can use this attribute directly as a predicate. So, and that's not how we've done it now. It's not certain that that will be the final version. That is now for the industry and the IMF group to discuss to see how we can do this in the most useful manner for the end users. All right, so I don't have an example of this in my shackle validator. This is basically, that works the same way as for the reference data used directly. All right, and then we have intervals. Like, that is something slightly different. That means that it looks the same in the shackle rule at the moment. We have we point to a path which is actually our attribute type, and then this attribute that is, instead of having one object value, it has a blank node here with two values, an upper and lower bound. So we need somehow a way to actually verify that this piece of information is is valid. And to do that, we need something more. We need some extra information in why did that move like that? We need some extra information. And the first thing we should do, I'm just trying to find those data. Yes. Let's see. We would like to add something extra. We change this here, the things that we should validate, and we said that, you know what, on this path, when we hit this attribute, then I have a completely new shape that I would like you to validate my data towards. And that shape looks like this, which is basically the same type of shape that we already seen. It has two different properties. It says that we should have this upper bound, which is not a proper reference term at the moment, but so that will be added, but this is just to show the concept. We have a lower bound and we have an upper bound. They should both be part of this interval. They are literals, and they should actually be of the type float. Those are all the requirements that are to ensure that this interval down here is correctly linked. So let's go to the shackle playground and see what we have. I've already included, I think, hope, no, didn't include that shape. So I need to include the shape itself. All right, then we do that. I'll just paste that in there. See, we have this extra interval type shape, yes, and then we needed to refer my repeatability to a node type. Yes, this is already in there. I've changed this to node in here. Right, but then we probably also need to do something with the data. Let's see, I'll update this, no change. We have my, I already have this in my data, right? And now, unfortunately, it is, if I now just say that this is of some other type, sorry, let's see. Let me try to change this to a string instead of a float. Like that, and update. And then that didn't work. Let's see. Where is my error? The IMF attribute is here. This should point to the interval type, yes. I should probably update this. All right. Why? I cannot see what I've done wrong there. Ah, there we have it. Yeah, yeah. We have more of those. Right. Okay. So now we see that we do not match this shape, which is hopefully because I've already changed this type here. Update that. Doesn't match the shape. So why is that? Interesting. So much for this demo, huh? It said that it does not have shape value type, interval type. Should be there. It should recognize it as being the blank node we have over here. I don't think I need to. Running out of time now also, so just have to try one more last thing before going onwards to the next step. See if this can jog it. Ooh, I got more. Well, it does not have shape. I must admit, I'm not sure why that failed, but I think I should move on at the moment. See if we can fix the other validation errors we have. Let's see. This should have kind of been a way to now, instead of using the original shape, move the validation of this object, this blank node down here, that should now be validated using the interval shape. And yeah, it worked yesterday. So moving on to the terminal and the blocks, which is the last part of this, they behave the same way. But we have this thing that we've used has value, and this was an error in the things that was introduced previously, because this expects us actually to have this value in our data. But we need to instantiate and say that our instance of our block has an instance of a terminal. And that instance of the terminal is not the same as the type of the terminal. So we need to change that. And one way we can change that is to, instead of using has value, we can use class. So we can try that first and introduce this this class parameter. Let's see. Go up here and say we have a class value here. Let's go to class, and we have a class here. And we will just push on with another class for the block as well, because they are similar. They have the same shape, structure. And now we got more errors. And why did we do that? Okay, because these values over here, the protocol specified signal output terminal, it doesn't have the class that it's supposed to have according to this. It doesn't have this terminal class over here. So now we need to add that information to the data itself. We basically need to add, let's see, probably have a shape. We need to add this information that the protocol specified signal output terminal, which is a long name, is of a type and then of this terminal type. So if we add that to the data, let's see, back to the shackle playground here, pasting in a bit of data just below here. So now we removed those error again, and we can see that we still have one that is not of class. Why is that? It's there. And it's there. Should be the same. Ah, okay. But what we have now is that we have this terminal down here. let me go back to this. We have now two terminals that both should be of a class, but the path is the same. It's has terminal, which means that if you have one terminal here, it will try to map it to both of these two, which means that this terminal is mapped to this class and this class, and it's only part of one of them. So we need a way now to say that, okay, we don't want to match you against all the different terminal classes out there. We want to match you against a particular terminal class. And Shackle actually have a method of doing that, and that's the conditional values. So, sorry, no, wait. So what we can do now is, yes, we have these two constraints on one terminal, and the implication is that both instances should be of both classes, right? And we also have errors when it comes to the cardinality, because both of these said that it should only be one, but we actually have two. What we can do then is update to use what is known as a qualified value shape and put our class definition within that shape and say that this should be, this condition here, the qualified value shape, should exist once. So if we now update our data with this information, we should see that most of these issues go away. Let's see. So I will replace in my shape the bottom three here. Let's take this.
FYI board, we have 6 minutes left.
6 minutes left, right.
I think we have to wrap it up in maybe 2 minutes, so we have time for at least one question.
Sure. And now we see that all the validation errors are removed, with the exception of this one that I'm not entirely sure what failed during this presentation. But now we have a system where we can say that, all right, we should have one of this terminal, and we should have one of this terminal, we should have one of this block, and perhaps three of this other block. This structure of the shackle shape handles those issues. And that means that this is our final shape. I should have brought in here now a picture of the IMF diagram, but yeah, I got sidetracked. Basically, there was another meeting that got priority. So, but now this is basically the final shackle shape that we are delivering through PCA at the moment. Yes, that's basically it. Questions? See, I cannot see the. I can, of course, try. I have what should be the final data, upload that to the various parts and see if there was just something that I did wrong.
In the meanwhile, is there any questions or comments, maybe? Mihaly, you have one question?
Yes, hello, Mihaly Fekete from Equinor. Very good and deep explanation and demo. Thank you for that. Not very tightly to today's demo, but it would be very nice to have some kind of idea and suggestions to how to use shackle shape, not for validation of the instance data set, but to the creation of the data set.
Well, that is that's basically up for the client application. They can download the shapes, and then they can fit their data to that. Say that this is my instruction. Basically, turn the purpose of Shackle upside down and say that this is my instruction for now creating an instance. And I need to then use this is the path, so this is my predicate, and these are the things that should be in that. But unfortunately, I think, yeah, there has to be created clients to actually perform that activity in the various companies.
Okay, thanks. So it means that we need to handle it a proprietary way, depending on the technology where you produce the data and you want to create the.
Yes, you need to somehow instantiate these types, and we don't, at the moment at least, we don't have any tool to actually do that. So
it could be maybe a subject for further development and the research together with the PCA organization, because it's a crucial thing that we have the library, we have the shapes defined, but how we can implement it in the different environment when we store the data in the different systems and get it out and form it according to the shapes and the ontology is important. But thanks, Lord, that was good.
Yeah.
Yeah, of course, I think that's something that should be discussed, whether PCA actually should provide tooling to instantiate these types. That is a very good suggestion, I think. But,
yeah.
Any other questions?
Just a comment. I think it's good that there was one error in the demo. Otherwise, it wouldn't be a live demo. So
Agree.
that's at least positive.
Yeah, I did something wrong. That's the final example that I had that showed no validation errors. So something went wrong.
Maybe one more question: is that the material available for the members of?
Sorry, can you repeat that?
Is that material available somewhere in a GitHub repo for the companies here?
This is we have let's see, we have these APIs which are where you can get the element types, for instance, where we should be able to just what happened there? There we go. Perhaps we should get this in Turtle instead. All right. So here you can get the information that we have. It's not out in the example I showed you now is not out in production yet, but we hope to have it in production by end of next week. I think we've promised. So yeah, and of course this is now a work in progress. I think we should be aware of that. So when now the users come with feedback and we see what parts of the IMF manual is working, what needs some work, how should we model the different things, we expect the actual IMF types to change. But there will be added, from next week I guess, it will be added more and more information that could be retrieved from these APIs directly.
Okay, thanks.
And we can share the links to these APIs at the moment, and then I'm not exactly sure. I don't think we've set a date for it, but this would move to postcaesar.org shortly.
Yeah, thank
But
you.
the production instance will be on postcaesar.org and not some Azure website.
We're also going to set up a technical session to basically provide some training for those that will be making use of this through the API and so forth. So if that's of interest, we can also add you there.
Thanks. Appreciate it. Yeah.
Very good. Thank you very much.
You're welcome.
And wish you all a happy weekend.
Thanks.
Thank
Nice weekend.
Yeah, thanks a lot.
Have a good weekend.
Great
Bye.
demo.
Good weekend.
Bye-bye.